everyone, this is the 2019 free response question number 4. So we're given this cylindrical barrel with a diameter of 2 feet that's collecting rainwater. The water is draining out through a valve on the bottom. The rate of change of the height is modeled by this equation right here, where h is measured in feet and t is measured in seconds, and they give us the equation for volume. So since we're given that the diameter is 2 feet, this means that the radius of the whole thing is going to be, oops, not 2, 1 foot. And that's going to be consistent. The radius doesn't change at all. So in part A, it says find the rate of change of the volume with respect to time when the height is 4. So if we're looking for the change in the volume with respect to time, we're looking for dV dt evaluated when the height is equal to 4. That's really what we're looking for overall here. So there's a couple of things we have to do first. Let's look at this volume equation. We know that volume is equal to pi r squared h. And we set up here that the radius doesn't change at all. It's always going to be equal to 1. So what that means then is that the volume in this case is always just going to be pi times h. So if I want to look for dV dt, that means I'm going to take the derivative of this pi h. So pi is just a constant, and the derivative of h with respect to time is dh dt. Now, we were told up here that dh dt is this negative 1 over 10 times the square root of h. So we're actually going to plug that in right there. So what that means then is the volume is equal to pi times negative 1 over 10 times the square root of h. So if we're looking for dV dt when h is equal to 4, we're just going to plug that in. So I'm going to write this as negative pi over 10 times the square root of 4. We know that the square root of 4 is 2, so this is going to become negative pi over 5. And now we do have to make sure that we include units on this one. So let's see, dV dt is going to equal negative pi over 5. And we need to figure out what the units are. Well, we're looking at volume, which we know is something cubed. And since the height is measured in feet, this must be cubic feet per, let's see, t is measured in seconds. And so there is our answer for that one. So this question was worth 2 points overall. It was 1 point for figuring out dV dt is equal to pi h. And then it's 1 point for your answer with your units. Okay, part B here. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? So we're looking at dH dt, right? The rate of change of the height of the water with respect to time. So is that increasing or decreasing when h equals 3? That's really what this question is asking. Well, in order to figure out if dH dt is increasing or decreasing, we need to look at the derivative of it. Well, the derivative of that would really be the second derivative. And if we can figure out whether that second derivative is positive or negative, we can tell whether dH dt is increasing or decreasing. So we're going to find the second derivative. Well, we know the first derivative is negative 1 over 10 square root of h. So we're going to take the derivative of that. So the negative 1 over 10 stays in front. The square root of h means it's a power of 1/2. So we're going to drop the 1/2 and subtract 1 from the exponent. But then we have to be careful here because we're taking the derivative with respect to time. So we're also going to need some implicit differentiation here, and we need our dH dt because we took the derivative of the h that was there. So now let's see what this is going to become. Let's see, negative 1 over 20, and the square root of h goes on the bottom. And then that dH dt that's there, this one here, is the same that we used up here. So negative 1 over 10 times the square root of h. And so if we look here, if we simplify that down, the square root of h actually cancels, the negatives cancel, and we're left with 1 over 200 for our second derivative. There's no variables left in it at all. So if we think about that, 1 over 200 is always greater than 0. And so because of that, we know that dH dt is increasing. So since d2h d2 squared is greater than 0 for all h, dH dt is increasing when h equals 3. All right, let's see. This one was worth 3 points. So it was worth 1 point for actually getting the derivative here. So knowing that you would leave the 1/10 alone, do the 1/2. So that was worth 1 point. And then it was worth 1 point for remembering the implicit differentiation. So that was really remembering this dH dt right here. And then it's 1 point for your answer. So saying that it's increasing. Okay. Now we're looking at, we've got the time t equals 0, the height of the water is 5. Use separation of variables to find an expression for h in terms of t. So we're going to go ahead and start out with dH dt is equal to negative 1 over 10 times the square root of h. So the first thing we do is multiply both sides by dt. And then we can divide by the square root of h. So we've really got dH over the square root of h is equal to negative 1 over 10 dt. And we're going to put in our integrals now that we've separated the variables. So I'm going to go ahead and rewrite this. Instead of the square root of h on the bottom, I'm going to make it h to the negative 1/2. And on the right side, I'm going to go ahead and do the antiderivative right away. So this is negative 1 over 10t plus c. And now I'm going to worry about the antiderivative on the left side there. So I'm going to add 1 to the exponent, which means I'm going to get h to the 1/2. And I need to multiply by the reciprocal, so I'm going to put a 2 in front. And so really, this is 2 times the square root of h equals negative 1/10 t plus c. So now that I've done the antiderivative on both sides, I need to be able to solve for c. So I need my initial condition. Well, we were given at time t equals 0, the height of the water is 5 feet. So that means I can plug in a 5 for the h, and I can plug in a 0 for t. And so obviously that cancels. And we get 2 root 5 is equal to c. Now we have to solve for h. So I'm going to go back up here. I'm going to do 2 times the square root of h is equal to negative 1/10 t plus 2 root 5. So in order to start solving for h, I'm first going to divide everything by 2. So I get the square root of h is equal to negative 1 over 20t plus the square root of 5. And now in order to get rid of the square root, I know I have to square both sides. So I get that h is equal to negative 1 over 20t plus the square root of 5 squared. And that's actually my final answer for that one. So for this question, it was worth 4 points. So it's 1 point for separating your variables. It's 1 point for taking your antiderivatives. I'm just gonna, I don't feel like writing that whole thing. 1 for your antiderivatives. It's 1 point for finding your C, and then it's 1 point for actually solving for H and getting your final answer. Now this one, there's just a couple things I want to note about those points there. It's an automatic 0 out of 4 if you don't separate your variables. So if you don't get to this step here where the variables are separated and you draw your integrals, they automatically give you 0 points on this question. All right. And then it's a maximum of 2 out of 4 if you don't remember to solve for C and solve for H. So if you were to get up to this point here, you would get a maximum of 2 out of 4 points. All right. Yeah, that was it. All right. Thanks, guys.